Hello everyone, welcome back to our channel. In this lecture series, we'll be discussing about the subject 8051 microcontroller BEC405A about module 1 discussing on 8051 pin diagram. In the last video, we have seen about 8051 architecture. The continuation of architecture is the description of pin 8051. Moving on to the 8051 pin diagram, you can see this is the pin diagram. So it is having 40 pin. So 8051 microcontroller is made up of 40 dual pins. So it starts from 1 to 40. Hope you can see this. So here 1 to 8 pin is port 1 and your port 2 is from 21 to 28 and your port 0 is from 39, that is 32 to 39, and third port is from 10 to 17. So the other ports are nothing but source, ground, VCC, that is your source, and you have ALE, PSEN, EA. So there are different types of pins available. Now you will be seeing the description also. So now here the port 1 is from 1 to 8. So these pins are bidirectional input output ports. So it can be used for interfacing with any external devices. If you take pin 9, that is RST, it is nothing but reset. So this pin has been used to reset the microcontroller with initial values. Pin 10 to 17 is port 3. So these are also bidirectional pin, that is this pins will have multiple function. Like it will act as interrupts, it will act as timers, control signals, serial communication signals. So for multi-purpose it has been used. So you can see how it has been multi-purpose. See here you can see T0, T1, that is timer, reading, writing, interrupt, receiving and transmitting pin. And then if you move on to the next pin, it is extal 1 and extal 2, that is 18 and 19. So these pins are used for connecting an external oscillator, crystal oscillator. Why? Because it is going to provide the clock signal for the microcontroller. Then pin 20 is nothing but the ground. So pin 20, it is being ground, it is you're grounding the microcontroller source and ground. And this VCC 40, so here this pin is provided for the power supply voltage, that is plus 5 volt will be provided across VCC. Then 21 to 28 you can see it is port 2, that is these pins are also bidirectional input output ports which can be used for many purposes. So see, it is not that it is only for input output. How the port 3 is used for many purposes, likewise your port 2 also will be used for many purposes. Then moving on to the next thing, that is PSEN. Port 29 is PSEN. So PSEN is nothing but program store enable. So this is called as program store enable. It is used during the process of fetching the instruction from the memory. When you are fetching the instruction from memory, you will enable this pin. And 30th, ALE and prog. So here ALE and prog is nothing but you are telling that you are going to perform some function, programming. You are enabling the address latch. So that is ALE and prog. 31st pin EA and PP. So EA and PP is, this is an external access input that has been used to either it is used for enabling or disabling the external memory interfacing. And then 32 to 39, if you see, it is port 0. So this is also bidirectional input output ports which is serving as the lower order address for your memory access. So first when you save data, you choose lower data address. So that is used in port 0. So these are the functions of each and functions and description of each and every pin. Moving on to the next topic. You have input output ports function in 8051 microcontroller. So you have port 0, 1, 2, 3, right? So for port 0, you can see 8051 is having 4 ports, and it is playing a crucial role in communication. So generally each of these ports is a 8-bit register, meaning it can handle 8 bits of data. So at a time it can handle 8 bits of data. So each and every individual pin within that particular port will either act as input or as an output. So you call it as it is a bidirectional pin. It is bidirectional in nature, allowing the microcontroller to either receive the data or send the data, senses the data, and also acts as an actuators. So moving on to the specific functions of each port. So this is port 0, description of port 1. Sorry, it is not port 0, it is port 1. You can see P1.X. So you have an external pull-up VCC. It is connected across the port, and you have a latch to enable either switch on or switch off logic 0 or logic 1. So you are writing a latch, and then you are reading the pin and reading the latch. So here port 0, the primary function is it is an 8-bit input output port for all the general purpose usage. So in some configuration, the lower address bus, which we saw in port 0, right, A0 to A7, it shares the pin with P0 during the external memory access. So this feature requires some careful configuration to avoid some conflict. So this is for port 0 and this is for port 1. So here you can see what I told you. It is going to have the lower address buses. So control lower address bus and data with the control it is having. You have a latch across it. And also you have mux function across your port 0. In port 1, here you can see it is strictly input port, which is used for any general purpose application. So it does not have any alternate function like sharing the data bus duties. So often it is being used for interfacing some simple buttons, LEDs, or any other digital displays, which acts as a dedicated input-output devices. Yes, so now you're clear with port 0 and port 1. So moving on to the next, port 2 and port 3. So you can see the diagram for port 2-bit and port 3-bit. It is almost same as your port 0. So here this port 2 is a function of an 8-bit input output port. It also shares the upper 4 bits. That is, see 2.4, it is from 2.1 to 2.7, right? 2.0 to 2.7. So here the upper bits 2.4 to 2.7, it is the upper data with the address bus A8 to A11. And then this is similar to P0 port. It is having careful configuration which is needed so that it can avoid the conflicts during the memory operations. So moving on to the port 3-bit, it is also more or like port 0. So it is a versatile port. You call this port as versatile port because it is used for various functionalities. It is not only used for input output, it is used for many other functionalities. So here the lower bit, that is 0 to 3 pin, will be used for general purpose, and 4 to 7 it is used for multiple function. Based on the application it is being used either as interrupt inputs, timer or counter, or serial communication for transmitting and receiving data serially. So for multi-purpose it is being used. So there are some special function registers within your 8051 microcontroller to configure these input output pins. So by setting some specific bit in that special function register, you are going to enable some of the pin in the port 0, 1, 2, 3, any of the ports. So application of input output ports is nothing but you are going to read the data, you are going to send the data, and you are going to send the data either serially or parallelly, and serial communication with the devices takes place when the data is being exchanged. So these are the pin description of 8051 and functionality of each and every port in 8051 microcontroller. Hope you have understood the concept. Thank you. Stay tuned for more information.